This is video 2.1.1. In this video, your objective is to understand what complex and imaginary numbers are and perform basic operations with them. When we're looking at imaginary numbers, the big question comes up, what are these numbers? Why are we using them? If you want some places to look for some applications, the good website I found was what's listed here. This is a neat place to kind of see the applications, because as a teacher I don't get to use the applications very much, nor do you as a student, but someday you'll get into a career where some of you will be able to use these things called imaginary numbers. And they come up a lot in engineering to describe different situations. So let's take a look at our first example and a reminder of what these things are. So you've learned about this before. The imaginary unit, we use the letter I. And remember, the imaginary unit is the square root of -1. Okay? So I squared, whenever we see I squared, we're going to replace it with -1 itself, because of course if we square any radical, we're just going to get the value that's on the inside. Okay? This comes out important because of what you're going to see here coming up to make sense of some of these operations we're going to do. Now, complex numbers are basically imaginary number plus a real number. A and B represent your real numbers here, where I is your imaginary, and you can't have B equal to 0, because if B were 0, then you'd have a non-complex number. You'd have no imaginary number there, so it wouldn't quite exist. A couple of other things to understand. If you have the following, if you've simplified a number to the following, 4 plus 2i all over 5, this is a complex number, but it's not written in standard form. The standard form is always to break it apart and write it separately, like this. So when we ask for information in standard form, it simply means you should have two separate numbers, a plus bi. It shouldn't be one big fraction, as you saw in the first part here. So let's take a look at our first example on how to perform some of these operations. So complex operations, let's see, we are adding 5 minus 11i plus 7 plus 4i. So we're simply going to add like terms. You think of the I as an x, those two are like terms, so together they make a -7i. 5 and 7 go together and we get 12. This is written in standard form and we're done with this problem. Take a look at the next one. Of course, we're subtracting. So once again, very simple process here. Since we're subtracting, we're going to change this to adding 11 plus 6i, -5i plus I. It looks like we have 7 i's plus 6. There's the second one, subtracting. Multiplying gets a little bit more interesting because we actually might have something interesting happen. Of course, we're going to distribute just like normal. We get 12i minus 20i squared. This is what we want to change. Whenever we see I squared, we want to change it to -1. So out comes the I squared, and in goes -1 where I squared was. So everything else will stay the same, 12i minus 20 times -1. So this will simplify further, of course, to 12i plus 20. Writing it in standard form, we should put the 20 first and the 12i second. There's your simplified product of 4i times quantity 3 minus 5i. Let's take a look at this next one. We're going to FOIL just like normal. We're going to keep our eye out for I squared. So we get -14. Okay, so continuing our FOILing, it looks like we're going to do the last ones, and we get a -35i. The inner, we get a positive 6i, and the outer, we're going to get a positive 15i squared. So this is where we're going to change this out to a -1 times 15, or -15. So that's going to cancel out to -15. So let's take a moment and simplify this. It looks like we're going to have -29, and then minus 29i. Okay, so this is simplifying. We want to make sure we put it in standard form, and we want to make sure we get rid of the I squareds because they're simplified into something better. So taking a look at the final example here, This example requires some interesting manipulations, something you definitely want to take notes on and pay close attention to when you see these in your assignment. This is a division problem, 7 plus 4i divided by 2 minus 5i. What's really important here is that we don't have a square root in the bottom, and we do have a square root whenever we have I in the denominator, so we have to get it out. And this is where the same thing comes in handy that you've been working with all year to get the square root out of the bottom, and it's called a conjugate. We've never officially called it a conjugate, but you've seen this. You've seen where these two, when you have a number like we usually do, a plus b, and we times it by a minus b, and we see that this results in a squared minus b squared. This is really important because remember, we want to get rid of this I because it's a square root and it's not proper. So what we do is we multiply by the conjugates, and conjugates are just defined as two terms that are comparable in this way, where one is a plus bi and the other one is a minus bi. Conjugates allow us to get this product. Now, of course, what we do to the bottom, we have to do the top. So we're going to times top and bottom by 2 plus 5i, the conjugate of the denominator. So top and bottom will be multiplied. So keep in mind that this creates a difference of two squares in the denominator. So we're going to have 4 minus, and then our last term will be, let's see, 5 times 5 is 25 times I squared. Okay. The reason, remember, is because these middle terms will cancel. That'll be negative 10i, and then it'll be, the outer terms will be positive 10i. So those terms cancel, which is the whole goal. We don't want any i's down there, because this simplifies to negative 1. So our denominator becomes 4 plus 25, or 29. So this is our denominator, 29. Of course, we need to multiply out for the numerator as well. So I'm going to do that off to the side here. Move this out of the way. So our numerator will be 14 plus 35i plus 8i for the inner term, and then the outer, plus 20i squared. This becomes negative 1, so we're going to have a negative 20 here instead. Combining like terms, our numerator becomes negative 6 for these two terms, plus 43i. So my new answer to this original division problem is going to be negative 6 plus 43i all over 29. This is equivalent to my original, but it's still not proper. It's not in standard form. So remember, to make it in standard form, we actually want to separate it out. So we're going to have negative 6 over 29 plus 43 over 29i. This is in standard form, and this is the proper solution for this problem. So the checkpoints are going to have you practicing this, so definitely rewatch the video and pause it and rewind if you have questions. So give these 3 problems a try. Make sure you write all your answers in standard form. So that involves the standard form of complex number is a plus bi. Of course, it could be a minus bi if b was negative. So take a moment to give these a shot and bring them into class with your questions.